Assalamualaikum warahmatullahi wabarakatuh, and so we will continue the discussion for chapter 1 matter, hour 3, question number 12. The question as follows: A. Define empirical formula and molecular formula. Just give this definition. You need to remember this definition. Okay, the keyword is simplest ratio for empirical formula, and molecular formula is actual ratio. And then determine the empirical formula as usual. Change the percentage to mass. I want to add from this question, from my answer here, you must assume. You must assume it is 100 gram of compound. The compound is 100 gram. You must make assumption. So from the assumption, you will get the mass of carbon and hydrogen from the percentage. Okay, and then just get the empirical formula CH2. And C, 0.25 gram of this compound occupy volume of 100 ml STP. Determine the molar mass and the molecular formula for hydrocarbon. 0.25 gram of this compound. Jadi, so this you need to identify the actual formula and molecular formula. Actual formula tu, actual number of the carbon and the hydrogen. So from the data given at STP, 34 liter of CH. Why is 1 mole? We understand from STP 1 molar is 22.4 liter. 1 mole is 22.4 liter. So from the calculation, we can get 4.4. The molarity, the mole is 4.4 4.464 exponent negative 3. Okay, so the molar mass is 56 gram per mole from this calculation. And then identify the N from the formula, molecular formula equal to N for empirical formula. This is empirical formula from CH2. So you need to find the N. The N. So you know the N. You will get the CH4, molecular formula CH4. So this is from here, CH4. So this is the final answer. Okay. Number 13, oxalic acid often used to, okay, as follow, you can read. It determine the empirical formula of oxalic acid. So same. You already has the mass, the percentage. Just change the mass to change the percentage to mass. So you must assume 100 gram of oxalic acid. This is the assumption you must do first, and then just calculate the empirical formula as usual. You will get CHO. Then what is the molecular formula? So given to you the molar mass is 90. So you use formula, molecular formula is equal to N for empirical formula, right? Okay, so N, what is N? You get N is 2. Okay, so the empirical times 2 for the empirical formula, you will get the molecular formula. Because empirical formula times 2 for the empirical formula. CHO2. So empirical formula, so kalau kita dapat N tu ialah 2. Okay, CHO2 times 2 lah. Dapatlah ni. And then question 14. Ni combustion data. Determine the empirical formula from combustion data. So the combustion of hydrocarbon give 1.1 gram CO2 and 0.45 gram of H2O. Molar mass of the sample is 84 gram. Determine the empirical formula. So you need to get the mass of carbon from CO2 and mass of hydrogen from H2O. So you get the mass of carbon from CO2 like this. Okay, find the composition of carbon in CO2. So that we will get 0.3 gram. And find the composition of hydrogen in H2O. You will get 0.05 gram. So 0.3 gram for carbon and 0.05 gram for hydrogen. So you will get the mass, so you can get the empirical formula. So CH2 empirical formula. So molecular formula is 84. So you will get N is equal to 6. So the molecular formula times by empirical formula. So molecular formula is C6H12. Number 15. The question as follows: calculate the mass of carbon, hydrogen, and oxygen in 2.3 gram of P, the sample P. Same like question number 14. This is percentage by mass. So you already know the compound P is carbon, hydrogen, and oxygen. So how much carbon in the sample, how much hydrogen in the sample? So because the product is CO2 and H2O, we can get the mass of carbon in CO2 and the mass of hydrogen in H2O. And then when you already get the mass of carbon and hydrogen, you can get the mass of oxygen by subtract the mass of carbon and hydrogen from the overall sample, like this lah. So 1.2 gram for carbon, 0.3 gram for hydrogen, and you can get 0.8 gram for oxygen. So as usual, when you get the mass, you can calculate the empirical formula, C2H6O. And then from the empirical formula, you can get the molecular formula, because you already know the mass of the compound is 46. So you can get then N is equal to 1. So molecular formula is same as empirical formula is C2H6O. C, write the balance equation. So balance equation like this. And that's all for our 3.